So we want to show that 1 minus sine A times 1 plus sine A over sine A cos A is cot A. I think it's fairly clear here that the sensible thing is to start with the left-hand side. There's plenty we can do with the left-hand side. So we've got 1 minus sine A, 1 plus sine A over sine A cos A. And I think expanding out is a good thing to do. So I'm going to get 1 minus sine A plus sine A and take away sine squared A all over sine A cos A. Well, the minus sine A and the plus sine A are going to cancel each other out. So I've got 1 minus sine squared A over sine A cos A. And of course 1 minus sine squared is cos squared. So I've got cos squared A over sine A cos A. And one of the cosines can cancel. So I've got cos A over sine A, which of course is cot A. So that's the same as the right-hand side. And then it says, hence solve this thing down here. Well, by comparison of this with this, I think we can write the left-hand side here as cot 3x. So cot 3x equals a half. And note that's something you can do even if you didn't manage to do the top. So cot 3x equals a half. And we're solving that for x between 0 and 180, which means initially we're going to be solving for 3x between 0 and 3 lots of 180, which is 540. So this means tan 3x equals 2. Remember the relationship with cot tan. And so I can get the principal value of that from my calculator, but I have to remember that I put the calculator into radian mode slightly earlier. So let's get it back into degrees and then do the inverse tan of 2. And that's 63.4 degrees. So principal value 3x is, I forgot what it was, 63.4 degrees. Okay, we set that up on a cast diagram. ASTC, so we've got 63.4 degrees. And the other one will be in the T quadrant down here, 63.4 degrees. And we have to collect angles from 0 to 540, which means essentially that we're going to be going around 1.5 times. So 3x is going to be, so we've got 63.4, and then we're going to go around here, and that's 180 plus 63.4, which is 243.4 degrees. And then we're going to keep going, and we got to 360, and then that one is going to be 423.4, and then we're going to keep going until we get to 540. That's where we're going to stop. We don't meet any more solutions there. So x is going to be, so what have we got? 63.4 divided by 3, which is, I'm just going to give it as 21. I can't really give decimal places. I should have stored more decimal places here knowing I was going to divide by 3. It doesn't matter. So 21 degrees and 243.4, divide that by 3. And that's going to give me 81 degrees. And then 423.4 divided by 3, 141. And those all nicely fit into the range. So we want to solve 10 tan squared y minus sec y minus 1 equals 0. It's almost a quadratic, but we've got a tan squared and we've got a sec y. But we do know that tan squared y plus 1 is the same as sec squared y, which tells me that tan squared y is the same as sec squared y take away 1. So I can say that's 10 sec squared y take away 1, take away sec y, take away 1 equals 0. And so 10 sec squared y, take away 10, I'll put that with the minus 1 over here in a second. So take away 11 equals 0. And I'm pretty sure we can factorize that. 10 sec y and sec y. Put 1 there, 11 there. And if I make this one a minus and that one's a plus, that will do it, which gives us sec y is equal to 11 over 10, or sec y equals -1, which is the same as having cos y is equal to 10 over 11, and cos y equals -1. And there's only one of those between 0 and 2 pi. The cosine is -1 when y is pi, 180 degrees. And the other one we're going to need to solve. So y is going to be the inverse cosine of 10 over 11. So we need to be back in radian mode. So get back to radians. And then we'll do the inverse cosine of 10 over 11. .429, 0.430. So that's the principal value there. It's a cosine, it's positive. So that's there and there. And that's 0.430 as well. So y is going to be 0.430 radians, or 2 pi take away 0.430. So about 5.853. So if we put all of our answers together, we've got 0.430 radians, pi, and 5.853 radians.